Hey, this is Rich here. I am recording a little bit of router configuration today on Cisco routers. Today we'll be setting up a couple links, point-to-points between three routers, as you can see outlined up here. And we'll also be establishing OSPF connections. Now, the reason why I am recording this video today, there's actually two reasons. One is I want to test the recording quality of the built-in recording software on my Mac here, and basically just see how it records, the quality of the voice, the quality of the picture, its frames per second, is it smooth, all that stuff. And two, I want to test uploading this to YouTube and see how that turns out. Actually, not really expecting anything as far as views or anything go, but I would really like to go through that process with a video of this nature and see how it looks after upload as well. So anyway, we'll go through the process here, and as you can see, I already have the network outlined up at top. We have a /30, or basically a point-to-point, between each router here, router 1, 2, 3, and then we also have a loopback address that we'll be setting up on each router. So just to be clear, none of this is actually configured already. The routers are here and hooked up and turned on, but that's the extent of anything that's done. Nothing else has been configured. So we're going to go ahead and do that now. We're in router 1 at the moment. As you can see, we booted up, all the interfaces are down, so we're going to go ahead and enter config mode. And why don't we start by adding the loopback address up here. So we're going to go into interface loop, and we'll just use 0. You can use whichever number you prefer there. As you can see, as soon as we type that command, the loopback interface pops up. For those of you that don't know, a loopback interface is a virtual interface on the router that's always up. So no matter what cables are unplugged, no matter what errors they are, this interface will always be up. So it's a good, a really useful tool as we start configuring more things and we terminate connections. It's a really good idea to use these virtual loopbacks because they're always up. So they're never going to go down unless you shut it down yourself, which don't do that. Anyway, we're going to configure this with 1.1.1.1. So IP address 1.1.1.1, and then our subnet mask for /32, which is a single address, is of course 255.255.255.255. And there we go. We don't have to no-shut this interface because, like I said, it's a loopback, always up. So we're good to go there. Now the next thing that we're going to do is we're going to go ahead and set up this IP on Fast Ethernet 01. So we're going to go ahead and enter that. IP address 10.0.0.1 and a /30. So the subnet mask for that is of course a 255.255.255.252. Now, because this is the normal interface, and we can see up here that it's actually down, we're going to basically do a no shut, even though it's not, it's admin down, right? So that helps here because now we've allowed it to turn up, and because it does have another connection, it's going to go ahead and pop up here. So that's really cool. So why don't we go ahead and take a look at that interface that we've configured here. You can see this duplex and speed auto are already configured on the interface. That was there. We're just going to leave that. And if we look at our loopback interface that we configured, interface loopback 0, you can see this doesn't have that because it's not a physical interface. It's a logical interface, right? So it doesn't have need for speed or duplex settings on it. Now, before we can do any testing here, we're going to have to move to the second leg of this on router 2. So we're going to go ahead and save our changes here, which can be done by our write mem or a copy running start. So you're basically taking the running configuration and putting it on startup when the router starts. A write mem does the same thing. So if we go to router 2, we're going to blaze through this one just a little bit faster. We're going to go ahead and set our loopback on here. which is 1.1.1.2, and that's a single IP address. And then we're going to configure fast Ethernet 00, 10.0.0.2, and that is a /30, and we're going to no-shut that interface here. So we can see that interface is now up. So we want to test the connection between router 1 and router 2, make sure everything's up there. We can see that the interface itself is up, so that's good. But we're on router 2, so why don't we go ahead and try to ping router 1's interface. So there we go, perfect. As you can see, the first ping failed. That's normal for new connections, as you know, the connection gets established there, so that's perfectly fine. Don't worry about that. Now that that's established, if we do it again, boom, all 5 success rates here. Never mind the latency here, because this is GNS3, so it's simulated, which is why we're seeing those crazy latencies. Obviously, 2 directly connected routers would be much lower than that. But so this is good. We can ping between router 1 and router 2. Obviously, the ping is a two-way traffic stream, right? So it's when we ping that address, it's actually coming out of router 2, hitting that interface, and then getting the replies back. So we know if we were to come into router 1 now and ping that interface on router 2, that would succeed. And you'll notice that this one did not lose the first packet. That's because that connection is already established from when we pinged from router 2 to router 1. Now, one thing that we cannot do, though, we're on router 1, so if we do a show IP interface brief, we can see the 2 IPs that we configured on here, and they match what we're expecting, right? Because that's what we just set up. We can ping our own loopback, right? And we can ping our own local interface, fast Ethernet 01. We can ping router 2's interface facing us on its fast Ethernet 00. But we'll wonder if we can ping router 2's loopback interface. And we'll notice that the first packet fails, and then the second and the third, and they'll fail forever because it's not a local connection. And this is where routing comes in. Because it's not a locally connected IP to router 1, router 1 does not know how to reach it. So it doesn't know how to get there and get back for the ping requests. So what we're going to be using today is a routing protocol called OSPF, or Open Shortest Path First. It's a very, very common routing protocol. It's basically manufacturer independent, so you can use it on Cisco routers, on Dell, HP, Juniper, you name it, you can use it there. So that's one of the reasons why it's very, very common. And also it is a very great protocol, but we won't go into the details on that today. That's going to be a whole video all on its own. So we're going to blaze through this really quick because, like I said, this video is more of a test than anything. We're going to go ahead and enter config terminal mode, and we're going to go ahead and set up our router. We're just going to use OSPF1. Now, best practice dictates that you hard code your router ID. You don't have to do this part, but I highly recommend it for any production environment, because you can figure out what your router ID is going to be based on the calculations that the routing protocol uses. However, as you're making changes 5 years from now, you could set a new router ID without even thinking. That router gets rebooted, and then something that you're depending on that router ID for will fail down the road, and you'll be left scratching your head wondering why. So it's better to just hard code it, always hard code it. That way it's hard coded, and if you ever want to change it, you got to go and change it. It's not a it's not a huge hassle. Yes, it will cause a little bit of downtime to do so, but at least you always know what your router ID is going to be. You're going to have control of that. It's not going to come back and bite you later. So we're going to go ahead and set our router ID to the loopback interface, because once again, it's always up, right? It's never going to go down no matter what we unplug. And then we're going to go ahead and add the networks. So in here, we're just adding the networks that we want OSPF to know. Now you'll notice that the subnet mask here looks a little strange. It's a reverse subnet mask. So if you remember from our configuration on the interface, we use 255.255.255.255. The reverse of that, 255 minus 255, is zeros. And we're going to add it into an area. Once again, not going to get into too much detail here because that's a whole video on its own. So then we're going to also add our interface, and you're probably thinking, hey, you're going to put a different reverse subnet mask here because it's a /30, not a /32 like the loopback. You are incorrect. Because we have a router facing a router here, we only want router 1 to advertise that it knows .1. If we give it the reverse of .3 here, which would be a /30, it's going to say I know and am 1 and 2. But router 2 is going to handle that too, so we don't want it to do that. We're going to give it 0 here. And that's literally the config. So we're going to go ahead and save our changes on router 1. Come back to router 2. We're going to do the same thing over again. We're going to set our router ID to our loopback. We're going to add the networks for the router ID or loopback. Throw that in area 0. Area 0 is always your core area, by the way. We're not going to get into the details too much there, but by default, if you're going to use one area, use area 0. Or if you're unsure what areas are, use area 0. So we're going to add our network into here. And we'll notice now, there we go, because we've added this one in here. This is the link address, and that's on both sides. Once that's on both sides, as long as there's IP connectivity between the two ports here, the MTUs match, and it's configured in the same OSPF process number, which we used one on both sides, and the same area number, and of course actually matches, then you can go ahead and see that our OSPF adjacency comes up. So basically that means the OSPF routing on this router 1 is talking to the OSPF routing on router 2 here, and we can see it went from loading to full, so that means that it is completely set up and ready to go. So we have routing between router 1 and router 2 now. So actually, if we do a show IP OSPF neighbor, we can see we're in router 2 right now. Router 1 is in a full state, which is what you want to see. That's good. And DR, DR means designated router. Once again, we're not going to get into that a huge amount right now. But then the other really important thing is the Stead Timer. Default dead timer is 40 seconds, so the clock starts at 40 seconds, starts counting down. But right around the time it hits 30, you should see that it starts over again. And that's because the other router here, router 1, is going to go ahead and send its hellos every 10 seconds. So basically what that means is if this dead timer ever hits 0, it's going to tear down that routing link. But basically this router 1, has to fail sending its hellos out 4 times before router 2 will actually tear that link down. Those are of course completely adjustable and configurable, but that's just the default settings. So we can see this is actually up, which is wonderful, right? So if we go into router 1 now and we try our ping again over to router 2's loopback, we'll notice that it works. Beautiful, isn't it? We can actually go show IP route and take a look at the routes that we've learned. So ignore this. This is just the basically index, if you will, the codes. We can see 1.1.1, which is our loopback here. It's directly connected, and it's on loopback 0. So C over here means directly connected. So it's not using any routing protocol to learn that IP because it's already here. I know how to get to an address that's on me, right? However, we can see 1.1.2 is just a little bit different. it says 110/11. 110 is the administrative distance, which is a whole video on its own, and 11 is the metric. So the metric basically is what the routing protocol determines which path to take when there's more than one path. So basically, because this is the next hop, it's hard to beat that. But if we had, say, a router 3 getting to router 1, that's going to have a higher metric. It's learning it from this address here, right, 10.0.0.2. That's the interface facing us from that router, how long it's known it, and which interface it's learning it from, which is learning it from our fast Ethernet 01. So pretty nifty. And of course this is expandable. If we just look, we did not set up fast Ethernet 01, so we're going to go through that really quickly. And we're going to throw this IP on our router 2. And no shut that. Oops, can't type today. And we're going to throw that in our routing. And we're going to save our changes. And then we're going to go ahead now and go to router 3, which we actually haven't touched yet. And we're going to throw our loopback address on there. And once again, that's a /32. We're going to enter interface fast 00. We're going to throw that on there. /30. We're going to no shut. Enter OSPF. We're going to hard code our router ID to the loopback because it's best practice. And actually, no, we're going to do this backwards this time. We're going to add 10.0.0.6 into here. And that should bring our adjacency up, even though we didn't enter the router ID into here, right? So we can see that did actually bring it here. So now the question is, from router 1, can we hit loopback on router 3 right now? The answer is no, and I'm going to show you. You'll notice it doesn't go through. We'll just wait for that to finish really quick. Okay, now let's do a show IP route, and we can actually add the OSPF flag at the end here if we just want to see what's being learned through OSPF. Which, let's just go ahead and see it all. But we can see that it's not learning any of it, right? It's really strange. So why is that? If we look at router 2, that's so interesting, right? Why is it doing that? Well, now if we're back on router 1 right now, if we look at this link here, 10.0.05 and .6, we can see that this is actually being learned. 10.0.0.4 is the network ID, because remember this is /30, so the network ID is 10.0.0.4, and the broadcast would be .7. So that's the two unused IPs on that /30, which is actually 4 addresses, but only 2 of them are going to be usable. So we're learning that, but if you remember, we're going back to router 3 now. We didn't add our network statement for our loopback. So if we add that really quick in router 3, and we save our changes, we go back to router 1, and if we run this show IP route again, we'll notice that it's popped up now. And now we can ping 1.1.1.3 from router 1. And that is a basic IP config and OSPF config in a nutshell. Depending on how this turns out, I may go ahead and do and upload more of these that are actually planned out a bit better. Like I said, this video is just a test, so absolutely no planning here. I just whipped it out in about 2 seconds, and we didn't focus on really any key prospects here or anything like that. But we'll see how this goes, and maybe we'll go ahead and make a series out of this. Routing switching, maybe a CCNA or a CCNA SP focused video. Anyway, have a great day.